Alright, number 13. It says a boy is pulling a 6 kilogram sled up a hill at a constant speed of 6 meters per second. The hill has a slope of 38 degrees and a coefficient of friction of 0.2. Determine the force applied by the boy in order to move the sled up the slope at a constant speed. Assume the boy pulls with a force parallel to the inclined plane. Alright, so free body diagram first. I'm going to draw it this way this time. Alright, this is our sled. FG always straight down. FN perpendicular to the surface. And we know we have an FA parallel to the surface going up the slope. But we still have friction here. Okay? So we'll have, it's a kinetic friction because we're moving. Draw our components in. Theta and theta. Alright, we know our angle is 38 degrees. Our mass is 6 kilograms. I'm going to go ahead and put Fg here as a given because we know it. So our Fg is 58.86 newtons. Alright, so, and we also know we have a constant velocity. So the speed given doesn't really matter here. We just know that we're moving at a constant speed. So that allows us to set something here. Alright, so our two net force equations. We have Fx. So let's say up the slope is positive, so we have that applied force. And then in the negative direction we have two forces. We have our friction acting against the movement, and we have our Fgx. Alright, now the constant speed comes into play, because if we have a constant speed we don't have an acceleration, so we know that our net force here is equal to 0. Set up in the y, we just have our Fn minus our Fgx, or Fgy, sorry, and that equals 0 because we're sitting on the surface. So since we're dealing with friction here, and we have a coefficient of friction, I forgot to put that down, 0.2, we know we're going to need the normal force, which is Fg, our y cosine of the angle, our Fg 58.86 newtons, cosine of 38 degrees. We get a value for Fn. Of 46.4 newtons. Alright, so we were looking for Fa here. So let's solve this equation for Fa before we move on. So our applied force equals Fgx plus F sub k. Apply our definitions, Fg sine of the angle plus Fn, let's rewrite that, mu times Fn. Alright, so if we look now that we've got this set up, Fg, we have a value. We know the angle, we know mu sub k, and we found Fn. So now just apply, we just have to plug in, and that'll solve our Fa. So Fa we already have our value here, 46.4 newtons. Now we just have to plug in. So we get an applied force of 45.5 newtons. All right, and this makes sense. If we look at this part of the equation here, this makes sense because if we're pulling this way, we not only have to pull against the gravity pulling it down the hill, but also friction. So you would have to apply with a force equal to both of them added together. So that's a good check on your signs if you're having issues with that, or because it's just algebra. But you can have this set up right, but if you do your algebra wrong, your negatives and positives are going to come out wrong over here. So another reason to stick with letters as long as you can before you plug in numbers. I always say put in numbers right at the end. There's a reason.